Now, superposition of the waves. Today we are going to see about the stationary waves and the resultant equation of the stationary waves. Now, in this case, we are considering a long uniform wire fixed between the two fixed points. When it is plugged at the center and released, two waves forms, but in they are traveling along the string but in opposite direction. So if they interfere with each other, the point at which two waves interfere, that point is called as node. So at this point, displacement is 0 and the amplitude is equal to 0. The point at which the displacement is maximum, that point is called as antinode and its amplitude is plus minus twice a. Now consider two waves of same amplitude and same wavelength. They are traveling along the straight line but in opposite direction. Their displacement equation is given by y1 is equal to a sine 2 pi nt minus x upon lambda of the wave which is traveling along the positive x axis direction. Another is second wave y2 is equal to a sine 2 pi nt plus x upon lambda traveling along the negative direction. The resultant of all the two waves is given by y. By superposition principle, the resultant of these waves is the sum of the two waves. So y is equal to y1 plus y2. So putting the value of y1 and y2 in this equation, we get y equal to a sine 2 pi nt minus x upon lambda plus a sine 2 pi nt plus x upon lambda. Now, we know that in trigonometric relation, this formula is, we have seen that sin c plus sin d is equal to twice sin c plus d upon 2 into cos c minus d upon 2. Let us take nt is equal to c and x upon lambda is equal to d. So putting this value in this equation and solving, we get the resultant displacement equation is y equal to twice a sine 2 pi nt into cos 2 pi x upon lambda. The result, but twice a cos 2 pi x upon lambda is the amplitude. So a is equal to twice a cos 2 pi x upon lambda. So putting this value in this equation, the resultant displacement is given by y is equal to a sine 2 pi nt, where a is the resultant amplitude and n is the resultant frequency. Now, in this case, we are saying that the amplitude is varying in the space, periodic in the space, that is, when from particle to particle, the amplitude is different, but every point on the string, the frequency remains the same. Amplitude is variable. Here, if we see this loop, in this, amplitude is minimum, then increasing. At this point, it is maximum, then decreasing. Means, particle to particle, amplitude is variable. It is periodic in the space. But frequency of the string remains the same. Now, in this case, y is equal to a sine 2 pi nt. These waves neither traveling in the backward direction or left side, neither traveling along the forward direction to the right. It remains stationary. Therefore, this wave is called as stationary waves. Now, the node distance between two successive nodes. This is one node N1 and this is another successive nodes. So, if we want to find out the distance between two successive nodes, we are considering this for node condition. The displacement at this point is minimum and amplitude is 0. So, A is equal to 0. But we know that A is equal to twice A cos 2 pi x upon lambda. So, putting the value of A equal to 0 in this equation, 0 is equal to twice A cos 2 pi x upon lambda. So, cos 2 pi x upon lambda is equal to 0, means 2A bringing this 0 divided by twice A is equal to 0. So, cos 2 pi x upon lambda is equal to 0. This means that the 2 pi x upon lambda must be equal to 0, pi, 2 pi and so on. So, if this is equal to the, if we are putting the value of 2 pi x upon lambda is equal to 0, then 2 pi x upon lambda is equal to 0, then x is equal to lambda upon twice pi, lambda upon twice pi. Okay, so x is equal to bring this lambda upon twice pi into 0. So x is equal to 0. So first node form at the distance x, then putting this value pi. So if we put pi get cancel. Second node form at lambda by 2. Third node form at lambda. Fourth node form at thrice lambda by 2 and so on. The distance between two successive nodes is equal to second node formed at this distance minus first node formed at this distance. So, distance between two successive nodes is equal to lambda by 2. Now, for antinode, the distance between two antinode when the form its displacement is maximum and amplitude value is plus minus twice A. We know that A is equal to twice A cos 2 pi x upon lambda. So, putting this value in this equation, we get twice A. We get twice A is equal to twice A cos 2 pi x upon lambda. So, bringing twice A this side cos 2 pi x upon lambda, twice A cancel. So, this cos 2 pi x upon lambda is equal to plus minus 1. That means we have to place 2 pi x upon lambda is equal to pi by 2, 3 pi by 2 and 5 pi by 2 and so on. So, in this also x is equal to lambda upon 2 pi, putting this value pi by 2. Pi get cancelled, x equal to lambda by 4. So first antinode form at the distance lambda by 4, second at distance 3 lambda by 4, next 5 lambda by 4 and so on. The distance between two successive antinodes is equal to lambda by second antinode formed at the distance thrice lambda by 4 minus first formed at the distance lambda by 4. So 3 lambda by 4 minus lambda by 4 is equal to twice lambda by 4 or 2 to the 4. So lambda by 2. So distance between two successive antinodes is also equal to lambda by 2. So distance between two successive nodes is lambda by 2. Distance between two successive antinodes is lambda by 2. Thus, the node and antinode are alternately formed. They are equally spaced. So this is the expression and these are the conditions for node and antinode.